जय हिंद बच्चों। आज हम लोग नया कुछ सीखने वाले हैं। तो सबसे पहले क्या सीखने वाले हैं ये जानने से पहले हम लोग देखेंगे कि आपको अगर एक पॉइंट के कोऑर्डिनेट्स दिए गए हैं, सपोज कोऑर्डिनेट्स ऑफ द पॉइंट इज 2,3, अगर ऐसा बोला गया है तो इससे आप क्या निष्कर्ष निकालते हैं? क्या आपने ये निष्कर्ष निकालते हैं कि x कोऑर्डिनेट 3 होगा और y कोऑर्डिनेट 2 होगा? नहीं ना। आप हमेशा ये निष्कर्ष निकालते हैं कि इस पॉइंट का, जिस भी पॉइंट का ये कोऑर्डिनेट्स दिया गया है उसमें x कोऑर्डिनेट हमेशा 2 होगा और y कोऑर्डिनेट या ऑर्डिनेट हमेशा आपका 3। तो ये एक अंडरस्टैंडिंग है कि फर्स्ट प्लेस किसका है, सेकंड प्लेस किसका है। तो इस तरह के जब दो टर्म्स एक साथ लिखे जाते हैं जिसमें कि फर्स्ट प्लेस और सेकंड प्लेस पे आने वाले एलिमेंट्स के बारे में क्लियर कट जानकारी दी जाती है, इफ इट इज फिक्स्ड व्हाट कम्स एट फर्स्ट प्लेस एंड व्हाट कम्स एट सेकंड प्लेस, देन इट इज कॉल्ड ऑर्डर्ड पेयर्स। तो ऑर्डर्ड पेयर्स में आप क्लियर कट बता सकते हैं कि फर्स्ट प्लेस पे क्या होगा, सेकंड प्लेस पे क्या होगा। नेक्स्ट है कि आपके पास अगर दो ऑर्डर्ड पेयर्स आपके इक्वल हैं, सपोज ऑर्डर पेयर ए बी इक्वल्स टू ऑर्डर पेयर सी डी, तो कॉरस्पॉन्डिंग प्लेस के एलिमेंट्स आपस में इक्वल होंगे, मतलब ए इक्वल्स टू सी होगा, बी इक्वल्स टू डी होगा। तो ये ऑर्डर पेयर का कॉन्सेप्ट है। इसी प्रकार से अगर आपके पास तीन एलिमेंट्स हैं तो तीन एलिमेंट्स के लिए भी आप बता सकते हैं कि उनका ऑर्डर क्या होगा। अगर उन्हें ऑर्डर में फिक्स करके आप अरेंज करते हैं तो दैट इज कॉल्ड ऑर्डर ट्रिपलेट। एंड 4 एलिमेंट्स के लिए, 5 एलिमेंट्स के लिए, इसी तरह आप n एलिमेंट्स के लिए अगर फिक्स करते हैं तो दैट इज कॉल्ड ऑर्डर्ड एंटपल्स। तो आज हमारा टॉपिक यही है, इससे रिलेटेड है, ऑर्डर्ड पेयर्स से रिलेटेड है। तो हम ये समझ गए कि ऑर्डर्ड पेयर्स क्या होते हैं। अब हम आए कार्टेशियन प्रोडक्ट ऑफ टू सेट्स। ये एक नया कॉन्सेप्ट है आपके लिए। व्हाट इज कार्टेशियन प्रोडक्ट ऑफ टू सेट्स? तो Cartesian product of two non-empty sets A and B is represented like this, and it is defined as set of all ordered pairs A comma B such that the first element belongs to set A and the second element belongs to set B. So this is how we define the Cartesian product of two sets. Now, if you define Cartesian product of two sets B and A, so it will contain the ordered pairs C and D such that C belongs to set B and D belongs to set A. Question arises कि क्या Cartesian product of A and B and Cartesian product of B and A are same? क्या ये दोनों आपस में equal होंगे? So what should be your answer? Just ponder on it. So your answer obviously comes out no, they are not equal. So you can see here also, in this case the first element belongs to set A, but in this case the first element belongs to set B. So if you have set A such as it has elements 1, 2, 3, and you have set B which has elements A and B, so the Cartesian product of A and B will be the set of all possible ordered pairs such that first element belongs to set A and the second element belongs to set B. So we start pairing. We always take the first element from set A and the second element from set B. So we start pairing one with A, one with B. So one has paired with both the elements. Now come to the second element, 2. 2 with A and 2 with B. Now come to the third element. 2 is paired with both the elements. The third element is 3. 3 with A and 3 with B. So we have completed the Cartesian product of set A and B, and it is this. Now we go for the Cartesian product of B and A. In this case, you have to take the first element from set B. That means either from A or B. And you have to pair it with the elements of set A. So we take the first element as A. A is paired with 1, so you have A comma 1. A is paired with 2, so you have A comma 2. A is paired with 3, so you have A comma 3. Now next is element is B. B should be paired with all 3, so you have B comma 1, B comma 2, B comma 3. So these are all possible ordered pairs. These are all possible ordered pairs. So you can see clearly this ordered pair is not equal to this, because the first element is not equal to the first element, second element is not equal to the second element. So it is very evident that the Cartesian product of two sets A and B is not commutative. These two are not equal. Now one thing more we need to discuss here. What is the number of elements in set A? Number of elements in set A is 3. What is number of elements in set B? It is 2. And what is the number of elements in set Cartesian product of A and B? So you will find out it is in total 6. What is the number of elements in Cartesian product of B and A? So you find out it is 6. So can we find out a relation between the number of elements in Cartesian product of A and B and the number of elements in A and number of elements in B? Yes, we can. So we can devise, we can find out, we can reach to a conclusion that if the number of elements in set A is P and the number of elements in set B is Q, then the number of elements in Cartesian product of A and B will be P into Q. That is number of elements in A into number of elements in B. So this is your one standard formula which you can use here. So that's what we have talked about the Cartesian product of two sets. Now if you take the Cartesian product of 3 sets, suppose we have A, B and C, 3 sets are there and we have to find out the Cartesian product of 3 sets. Then you have to take ordered triplet instead of ordered pairs, what we have taken here, you have to take ordered triplets. So the Cartesian product of A, B and C will have ordered triplet A, B and C such that the first element belongs to set A, the second element belongs to set B and the third element belongs to set C. So in this way you can define, you can go for Cartesian product of n sets. So with the concept of Cartesian product of two sets, we are ready to move and to take some examples. So I am taking some examples, few examples from exercise 2.1. So the first example is first question, that is two ordered pairs are given equal, that is x by 3 plus 1 is the first ordered pair and y minus 2 by 3 is second ordered pair. These two this is equal to 5 by 3 comma 1 by 3. So as you know that if two ordered pairs are equal, then the first element will be equal to the first element. Therefore x by 3 plus 1 will be equals to, yes, answer 5 by 3. Now next one is y minus 2 by 3 will be equal to, please answer, please participate. So you have 1 by 3 and x by 3 is equals to 5 by 3. Rest is equation, solving of equation, and we have learned well. So the first step is a new thing for this chapter, rest is old, nothing new in this. So after solving it you will get 5 minus 3, 2 by 3 into 3 and y is equals to 3 by 3, that is equals to 1 and x equals to 2. So in this way we found the values of x and y. Now let us move to the next question, and they are very easy I think. So you can enjoy this, and let us move to the 10th question. Basically 10th question I am taking to how to write the answer, that is important in this case. So please read the 10th question. To read a question very carefully is very important, because in every question it is important to find what is given to you and what you have to find out. If you know where you are and where you have to go, you can easily find out the way. So if you open your Google map, you have to find out your location and you have to mark the location where you have to reach, and then only it will give you the path. So your brain is like Google map. So give your brain the beginning of the location and where you want to reach, that is A and Cartesian product of A and A you have to find, then your brain will guide you. So let us begin. This question says the number of elements in Cartesian product of A and A is 9. Number of two elements are given in the Cartesian product A and A. One first order pair is -1, 0 and second order pair is 0, 1. We have to find out the set A and the Cartesian product of A and A. So let us begin. So we have to assume let the number of elements in set A be x. Obviously, then the number of elements in Cartesian product of A and A will be number of elements in A multiplied with number of elements in A. You have given number of elements in Cartesian product of A is 9. Number of elements in A we have considered x. So you have x square equals to 9. And number of elements present in a set is always a natural number. So x cannot be equals to -3. The answer is x equals to 3. So you found the number of elements in set A is 3. Now it is next step is to find out what are these elements. So you have to use given again. So you have -1, 0 belongs to Cartesian product of A and A. It is given to you. From here you conclude this implies the first element belongs to the first set and the second element belongs to the second set. So you have two elements in A are here, but total number of elements in set A are 3. So you have to search for the third element. So you have to go for the second thing given to you, that this ordered pair 0, 1 belongs to Cartesian product of A and A. It is also given to you. Now this gives you 0 belongs to set A and 1 belongs to set A. This implies you have in total 1, 2, 2 and 3 elements in A, and total number of elements in A is also 3. So you found the set A. So you have the set A as -1, 0, 1. So the first part of to find you have completed. First target is completed. Now you have to find out Cartesian product of A and A. So you will proceed further with all possible ordered pairs. So -1 paired with itself, -1 paired with 0, -1 paired with 1. Now go for the second element, 0 paired with -1, 0 paired with itself, 0 paired with 1. Now go for the third element, that is 1 paired with -1, 1 paired with 0, 1 paired with itself. So you found the Cartesian product of A and A. Also you found the number of elements in A and the set A. Now we have to go to a new concept that is called relation of a set to another set. Relation R from a non-empty set A to a non-empty set B is the subset of Cartesian product of A and B, and this subset is derived by describing the relationship between the first element and the second element. So obviously Cartesian product of A and B contains the ordered pair, so its subset will also contain the ordered pair. So you have first element here and the second element here. So suppose in a relation ordered pair A comma B is present. This is present in the relation R. Then in this case B is called image of A and A is called pre-image of B. So let us move further and find out further what is this is a relation. We need to find out now how to describe a relation, how to represent a relation. So to represent a relation, if you are algebraically want to represent it, you have roster form, you have set builder form. If you want visual representation, then you have arrow diagram. So let us consider a set A which has these three elements and set B which has these three elements. Now let us define or describe a relation from A to B which contains the ordered pair AB such that A is in the set A, B is in the set B, and the B can be given as A plus 2. So this describes a set builder form of this relation. Now let us go for roster form. In roster form you have to directly write down the elements. So if you take A as 1, A 1 plus 2, 3 will be B. So you have 1 comma 3. If you take B as 3, A as 3, then 3 plus 2, 5 is B. So you have 3 comma 5. If you place 4 in A, you have 4 comma 6. So this relation R is in roster form now. Now the last is the arrow diagram for visual representation. So you have set A, it has elements 1, 3, 4, and set B, it has elements 3, 5, 6. Now a relation R, 1 is related with 3, 3 is related with 5, 4 is related with 6. So this is arrow diagram representing the relation. Now let us know something more about our relation. If we take the first elements of the set or the relation, then it forms the domain of the relation. So domain of this relation R is all the first elements of the ordered pairs. So they are 1, 3 and 4. Now next thing is range. So range of the relation is set of all second elements of the ordered pairs. So all the elements which are present at the second position will be there in range. So range will contain 3, 5, 6. So what two very important definitions are here. Domain is the set of all first elements present in the ordered pair of the relation. Similarly, range is the set of all second elements present in the relation, second elements of the ordered pair present in the relation. So domain is this and range is this. Now come to the codomain. The concept of codomain says if R is a relation from A to B, then B is codomain of R. So whether it is present in the ordered pair or not, its elements are present there or not, it doesn't matter. The codomain is the second set. If R is a relation defined from A to B, then its codomain is B. Now let us go for the number of relations that are possible from set A to set B. If the number of elements in set A is P and the number of elements in set B are Q, then the number of elements in Cartesian product of A and B will be PQ, as we have discussed just now. Then what is the total number of possible subsets of Cartesian product of A and B? तो if a set has n elements, किसी set के पास अगर n elements हैं तो उसके number of subsets 2 raised to the power n होते हैं. तो number of possible subsets of Cartesian product of A and B are, that is number of elements in the power set of Cartesian product of A and B you can say are 2 raised to the power p into q. So you can say that the number of relations from A to B is 2 raised to the power p into q. For example, if set A has 3 elements, set B has 2 elements, then the number of possible subsets is 2 raised to the power 3 into 2, that is 2 raised to the power 6, that is 64 subsets are, or 64 relations are possible from set A to set B. If you have number of elements in set A as 2, number of elements in set B as 3, then the number of relations from A to B are 2 raised to the power 6. Now let us consider one question from the exercise, that is question number 5. So as usual, first step we go write down the what is given to us. The given is a set A 1, 2, 3, 4 and 6, and you have a relation defined on set A. If we are defining a relation from set A to set A, it is also called relation on set A. So now this relation is defined such that the second element should be divisible by the first element. First thing we have to do, we have to write down it in roster form. So let us write down the relation R in roster form. So we will pick up 1. So 1 is divisible by itself 1. So ordered by 1 comma 1 is there. Now let us take the second element 2. Now what comes out at the first place? So 2 is divisible by 1. 2 is divisible by itself, so these two elements are there. Now take the third element 3. So 3 is divisible by 1 and 3 is divisible by itself. Now take the another element 4. So 4 is divisible by 1, 4 is divisible by 2 and 4 is divisible by itself. Now take another element 6. So 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3, 6 is divisible by itself. So the total possible elements in the roster form are these. Now the second step we have to do, find the domain. So all the elements which are present at the first place will give you the domain. So you have first place 1 at the first place. So let us keep on writing. Domain has 1, 2 is on the first place, so domain has 2, 3 is on the first place, so domain has 3, 4 is on the first place here, so domain has 4. Anywhere 6? Yes, 6 is here at the first place, so domain contains 6 as well. Now third thing is range you have to evaluate. So for range we will look at the second place. So what is present in second place? 1 is there in second place, okay. 2 is there in the second place, 2, 2, 2. 3 is there in second place, 4 is there in second place, 6 is there in second place. So all the elements which are at the second place are in the range. So I hope you understood well the ordered pairs, the relation, the Cartesian product. We will meet again in next class with relation and function. Thank you so much.